Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at the Minnesota Department of Health. We're looking at vulnerability assessment parameters. Why is this important? It's going to give some idea of different chemical parameters such as ammonia, chloride, bromide, arsenic, things like that. And based on that, you can see what's going to happen, where it comes from, and what do the results mean when you get them. And with all of these, we can get an idea what's going on with our water and how to handle it. So just some background, the Source Water Protection Unit commonly samples raw groundwater for the following parameters and helps determine aquifers' vulnerability to contamination. And the abbreviations here are milligrams per liter, micrograms per liter, maximum containment levels, and Environmental Protection Agency for the EPA. So first we have ammonia, and it usually comes from the environment, decaying organic matter, but it can also come from human activity, waste, agriculture, or feedlot runoff. So what do the results mean? Long-term ingestion of water containing more than 1 milligram per liter may damage internal organs. There is no MCL, maximum containment level, for ammonia in drinking water, and the National Academy of Science recommends a drinking water standard of 0.5 milligrams per liter. In 1990, the EPA issued a lifetime exposure advisory of 30 milligrams per liter. Then we have arsenic, which is in the environment. We have soils and rocks, human activity, pesticides, and wood preservatives. And drinking water with low levels of arsenic over a long time is associated with diabetes and risk of cancers of the bladder, lungs, liver, and other organs. And the MCL for arsenic in drinking water is here. However, the drinking water with arsenic at lower levels than the EPA standard over many years can still increase cancer risk. We have bromide. The environment, rocks, maybe soils, and also human activity as well, road and water, soft and salt, fertilizer, and wastewater. Naturally occurring in groundwater typically has a concentration of less than 0.06 milligrams per liter, and at that concentration, the bromide itself is typically not a risk to humans, and the WHO recommends that 6 micrograms per liter for adults and 2 micrograms per liter for children. Then we also have chloride. That's in the environment and also human activity, and the toxicity has not been observed in healthy humans, and concentrations in excess 250 milligrams per liter may impart a bad taste to water. The EPA has a non-enforceable secondary standard for chloride drinking water as well. Then we have chloride-bromide ratio, and just to take a look, this is just the ratio, and it's a useful indicator of salt, and typically the ratio is less than 300, indicates a natural source. Then we have nitrate. That's in the environment as well, and human activity, fertilizers, discharge, sewage systems. Consuming too much nitrate can affect how the blood carries oxygen and cause methemia blue baby syndrome, and it can result in serious illness or death. Levels above 3 micrograms per liter suggest human-made sources of nitrate have contaminated the water. Then we have sulfate that comes from the environment. People unaccustomed to drinking water, so elevated sulfate can get diarrhea, dehydration. As a precaution, sulfate level exceeding 500 micrograms per liter should not be used in the preparation of infant formula. Older children and adults accustomed to high level of sulfate after a few days. If sulfate in the water exceeds 250 micrograms per liter, a bitter medicinal taste may render the water unpleasant. Then we have oxygen-18 and deuterium, environmental precipitation. The variations of deuterium and oxygen-18 composites support conclusions about climatic conditions and water sources during groundwater recharge. Values of precipitation that have not been evaporated are linear related and pilot on global meteoric waterline. And finally, tritium, and that is just from the environment. Now, this is a radioactive isotope of hydrogen with a half-life of 12.4 years, and concentration is measured in tritium units, TU. Natural atmospheric tritium is also generated by secondary neutron cosmic ray bombardment of nitrogen, which occurs the carbon-12 and tritium atoms, and combined with the oxygen forming water, subsequently falls as precipitation. Prior to atmospheric nuclear bomb testing in the 1950s, tritium's national average concentrations ranged from approximately 2 to 18 to 8 TU, and massive amounts were added in the northern hemisphere. So those are some contaminants definitely to be aware of. A lot of them can cause a lot of issues. Some of them are not as harmful in small quantities. But with that being said, it's always a good idea to have your water periodically tested for compounds like these.